Continuous solar, you've got, you actually don't need batteries because it's always sunny in space.
Right. You have felt it. You are driving through the mountains, or maybe just a stretch of highway between cities, and the signal bars on your phone vanish. The music stops streaming, the map freezes, you are disconnected. For 20 years, carriers have promised nationwide coverage, but you know the reality. Dead zones are everywhere. The physics seemed impossible to beat. Cell towers need land, power, and cables, and they just cannot go everywhere. But something happened that changes this equation permanently. Elon Musk and SpaceX just closed a deal worth $17 billion. That is a number you should pay attention to. $17 billion. They are not buying another company or building a factory. They are buying invisible real estate. Specifically, they are acquiring the AWS-4 and H-block radio spectrum from EchoStar. This sounds technical, but it is the key to the lock. This spectrum allows satellites to talk directly to the phone already in your pocket. No special apps, no big satellite dishes, just your standard phone connecting to space as if it were a tower next door. This is the moment the impossible became practical. The problem has always been physics. A cell phone has a tiny antenna. It pushes out a very weak signal, maybe half a watt. Trying to get that signal to a satellite moving 17,000 miles per hour, hundreds of miles above your head, is like trying to hear a whisper in a hurricane. For decades, engineers said it could not be done without a satellite phone the size of a brick. They were right, until now. SpaceX looked at the problem differently. Instead of making the phone louder, they made the satellite smarter. They are building a network of 15,000 satellites. Each one acts like a cell tower in the sky. But unlike a tower that stands still, these are flying in a precise web. They use the spectrum from this new deal to listen for that tiny whisper from your phone. The H-block spectrum is perfect for this. It sits in a frequency range that travels well through air and even some obstacles. It does not get absorbed by rain as easily as higher frequencies. When you combine that with the AWS-4 band, you get enough width to carry real data. Think about that for a second. You are not just getting a text message through. You are getting LTE and 5G speeds. Engineers have already tested this. They saw download speeds hitting 100 megabits per second. That is faster than the home internet many people pay for today, and they did it with a phone that was not modified. That is the breakthrough. The phone did not know it was talking to space. It just saw a signal and connected. The deal with EchoStar is structured to make this happen fast. The target closing date is November 30th, 2027, but the satellites are already launching. SpaceX is not waiting for the ink to dry to build the hardware. They have over 600 direct-to-cell satellites in orbit right now. They are launching dozens more every single week. This is where the competition gets left behind. Traditional satellite companies take years to design one bird and months to launch it. SpaceX builds them on an assembly line and throws them into orbit 60 at a time. You already know that speed matters in business, but here, speed is the product. The sheer number of satellites solves the second big problem: capacity. If you have only a few satellites, they get clogged up when too many people try to talk at once. It is like a traffic jam on a one-lane road. By putting 15,000 satellites up there, SpaceX is building a superhighway. Each satellite handles a specific patch of ground. As it flies over, it hands your call to the next one, then the next one. This handoff is where the real magic happens. It has to be seamless. If there is a delay of even a split second, your call drops. The software on board these satellites is doing complex math in real time. It calculates exactly where your phone is, where the satellite is going, and where the next satellite is. It switches the signal before you even notice a blip. This is technical mastery on a level that ground-based telecom companies have never had to deal with. Here is the thing most people miss. This is not just about phone calls. This is about data. The network capacity is staggering. Each of the new Generation 2 satellites has a total capacity of 700 gigabits per second. When you add that up across the whole constellation, you are looking at over 10 petabits per second of capacity. That is a number so big it is hard to visualize. It means millions of people can be online at the same time in the middle of nowhere without slowing the system down. The Spectrum deal unlocks this. Without those specific radio waves, the satellites are just flying metal. They need the legal right to transmit on frequencies your phone understands. That is what the $17 billion bought. It bought the road for the trucks to drive on. EchoStar held this spectrum for years. They tried to build networks, but they never had the launch power to scale it up. SpaceX has the rockets, they have the Starship, they have the Falcon 9. They match the resource to the capability. You see the strategy here. It is not just about being a phone company. It is about being the only phone company that works everywhere. T-Mobile was the first partner to sign up. They saw the writing on the wall. They knew they could never build towers in the middle of the Nevada desert or the Rocky Mountains. It costs too much. But by partnering with SpaceX, they suddenly have 100% coverage. Their map goes from spotty to solid. Other carriers are now scrambling. AT&T and Verizon have spent billions on ground networks. They have dug trenches for fiber and climbed poles to hang antennas. They have a massive sunk cost in the old way of doing things. Now they are watching a competitor skip all that digging and just launch the network into the sky. It is a classic leapfrog move. While they are fighting for permits to build one tower, SpaceX launches a rocket with coverage for an entire state. The engineering inside these satellites deserves respect. They are not big, heavy buses like the old TV satellites. They are flat, sleek, and packed with phased array antennas. A phased array is a grid of tiny transmitters. By changing the timing of the signal from each tiny dot, they can steer the beam of radio waves without moving the satellite. It acts like a spotlight, tracking your phone as it moves across the ground. This focuses the energy exactly where it is needed. This efficiency is crucial because power is limited in space. You rely on solar panels. You cannot just plug into the grid. The engineers had to design radios that are incredibly sensitive but use very little juice. They also had to figure out how to handle the heat. When you push gigabits of data, chips get hot. In space, there is no air to cool them down. SpaceX developed radiative panels that dump heat straight out into the cold of deep space. It is a clever solution to a hard physics problem. And then there is the laser network. This is the part that turns the constellation into a global web. Each satellite has laser links that connect it to its neighbors. If you make a call from the middle of the ocean, the signal goes up to a satellite, shoots across lasers to another satellite over land, and then down to a ground station. It moves at the speed of light in a vacuum, which is actually faster than light in a fiber optic cable. That means the latency, the delay on the line, is incredibly low. You are looking at 20 to 40 milliseconds. That is fast enough to play video games. It is fast enough for stock trading. It is fast enough that you will not feel that awkward pause in conversation. Old satellite internet had delays of half a second or more. It made talking impossible. This system fixes that permanently. You have seen the pattern before. People doubt Elon Musk's timelines. They say the rockets will blow up or the cars will not work. Then the team puts their heads down, iterates, and delivers. This mobile network followed the same path. Early tests had issues, signals were weak, interference was a problem, but they treated every failure as data. They tweaked the software, they adjusted the orbit. Now the system works. The FCC approval was the final green light. Regulators looked at the plan and signed off. They saw that this was the only way to truly close the digital divide. Billions of dollars have been spent by governments trying to wire up rural areas with very little to show for it. This private solution does it without digging a single ditch. It is resource efficiency quantified. Competitors are trying to catch up. Companies like AST SpaceMobile are building massive satellites with giant unfolding antennas. It is a different approach. Their satellites are huge and complex. SpaceX went with smaller and more numerous. If one SpaceX satellite fails, the network barely notices. If a giant competitor satellite fails, you lose coverage for a whole region. The swarm approach is more resilient. It is harder to kill. You also have to look at the launch advantage. SpaceX owns the rockets. They launch at cost. Everyone else has to pay SpaceX to get to orbit or wait for rockets that do not exist yet. Blue Origin is years behind. European rockets are expensive and rare. China is building its own constellations, but they are launching much slower. The gap is widening every day. By the time others get 100 satellites up, SpaceX will have another 1,000. The deal with EchoStar also cleans up a financial mess. EchoStar had debt. They had spectrum they were not fully using. This deal gives them a lifeline and puts the asset in the hands of someone who can use it. It is a rational consolidation of resources. SpaceX pays about $2 billion in interest payments to keep the deal smooth until 2027. It is a calculated cost to secure the future of the network. Think about the implications for emergency services. When a hurricane hits, cell towers are often the first things to go. Power cuts, wind damage, or flooding takes them offline just when people need them most. Starlink satellites are 200 miles up. They do not care about the wind. They do not care about the flood. As long as you have battery in your phone, you have a line out. Firefighters in remote forests can coordinate without carrying heavy satellite radios. It saves lives. This is justice through consequences. The market rewards the company that solves the hardest problem. For a long time, rural customers were treated as second-class citizens by telecom giants. They paid high prices for terrible service because there was no other choice. SpaceX broke that monopoly. Now, a farmer in Nebraska gets the same connection quality as a banker in New York. That levels the playing field in a way no regulation ever could. The sheer scale of 15,000 satellites is hard to comprehend. We have never had that many active objects in orbit. Managing the traffic is a nightmare. SpaceX built an automated collision avoidance system. The satellites talk to each other and dodge debris or other spacecraft on their own. They use electric thrusters to make tiny adjustments. It is an autonomous traffic system in the sky. And this is where it gets interesting. The phones are just the start. This network connects everything: cars, trucks, shipping containers, drones. Imagine a trucking company that can track every vehicle in its fleet in real time anywhere on Earth without paying for expensive roaming data. Imagine a drone inspecting pipelines in the tundra, streaming video back to a control room in Texas. The spectrum handles it all. The $17 billion is a lot of money, but look at the revenue potential. The global telecom market is worth trillions. If SpaceX captures even a small slice of the roaming market, the dead zone market, and the maritime market, the investment pays for itself 10 times over. They are not just selling minutes, they are selling reliability. They are selling the guarantee that you are never alone. You have felt the anxiety of being cut off. We all have. It is a modern fear. This technology removes it. It turns the entire planet into a coverage zone. The no service message on your phone is about to become a relic of the past, like a dial-up modem sound. It is a change you will tell your grandkids about. The timeline is set. By the end of 2025, the testing was already proving the point. By 2026, the rollout expands. By 2027, with the EchoStar deal closed and thousands more satellites in orbit, the network becomes robust. It is happening fast. You do not have to wait a decade. The hardware is leaving the ground right now. The genius of using the AWS-4 and H-Block bands is that they are already in your phone. Every modern smartphone has chips that can read these frequencies. You do not need to buy a new device. You do not need to sign a new contract if your carrier partners with Starlink. It just works. That lowers the barrier to entry to zero. That is how you get a billion users. Competitors like Amazon's Project Kuiper are still in the prototype phase. They are building good hardware, but they lack the launch cadence. They have booked launches on rockets that have not flown yet. Meanwhile, Falcon 9 flies twice a week. Starship is coming online to carry even bigger payloads. The momentum is unstoppable. It is like trying to catch a Ferrari on a bicycle. This is what mastery looks like. It is not just one good idea, it is 1,000 good ideas stacked on top of each other. The rocket, the satellite chassis, the antenna, the software, the spectrum deal, the ground stations. Each piece reinforces the others. If you take away one, it might still work, but together they form a moat that no one can cross. The financial analysts are starting to wake up to this. For a long time, they thought Starlink was a niche product for people. Now they see it is a direct threat to the core business of major tele. If you can get service from space for a competitive price, why do we need so many towers? The industry will have to adapt. We might see towers disappear in rural areas, replaced entirely by the Sky network. You were right to suspect that the old way of doing things was inefficient. Digging holes and running wires to every house is slow and expensive. Beaming data from space is the logical end state. It just took a company crazy enough to build 15,000 flying routers to prove it. The deal also includes a clever two-step transfer of licenses. They go to a trust first. This protects both companies while the government does its. It shows that the lawyers are just as sharp as the engineers. They anticipated the regulatory hurdles and built a bridge over them. Nothing was left to chance. As you watch this unfold, remember the numbers: $17 billion, 15,000 satellites, 700 gigabits per second. These are the metrics of a new era. The dead zone is dying. The global grid is turning on. And for the first time in history, communication is truly leaving the ground. This victory is confirmed by the data. Speed tests do not lie. Coverage maps do not lie. The satellites are up there and they are working. The competition is stuck on the drawing board or stuck on the ground. SpaceX has defined the future of mobile communication. It is seamless, it is global, and it is here. You will never have to look at 0 bars again.